there. In the last video, we talked about solutions to quadratic functions, and those happened when the graph, or we call that a parabola, crossed the x-axis. Now, today we're going to talk a little bit more about parabolas, those graphs of quadratic functions. So first of all, we need to remember that a parabola is a graph of a quadratic function. And they look like this. They could either be like a normal shaped U-type shape, or they could be upside down like this. But either way, both of the ends are either both going up or they're both going down. Now the first kind of key word here when we can talk about or describe parabolas is the vertex. Now the vertex is the highest or lowest point. So it's either down here or it's up here. If it's down here, we call the vertex a minimum because it's the lowest point. The minimum is the lowest point. If it's up here, we call it a maximum because it's the highest point. So here we can write that the vertex is a minimum. And up here, we can write that the vertex is a maximum. Now, we can also describe these shapes. We keep talking about how it's like a normal U or an upside down U. There's actually a better way to say that. If it looks like this, we say that it opens up because the opening is up or at the top. If it looks like this, we say that that parabola opens down because the opening is at the bottom or down. Now we can also describe what the ends are doing. If it looks like this, they both are going up. If it looks like this, both of the ends are going down. So the end behavior really just describes whether each end is going up or down. So in a parabola that opens up, both ends are going up. So there's two different ways that you can write the end behavior. There's actually more, but two different ways that we're going to talk about now. One way is like this. We could say that the left side is going up and the right side is going up. And using this is kind of like the notation that we use to say end of behavior, that both sides are going up. Or we could write it like this, with arrows instead of words. Both of those are ways that you could write the end behavior. Now, it's possible to have functions or graphs that are like up, down, or down, up if both of the ends aren't going in the same direction. But in a quadratic function, the parabolas always have both ends going up, or in this case, both ends going down. So we could say down, down, or we could show that with arrows. We talked about in the last video that the solutions are the x-intercepts. So that's another way that we can talk about parabolas. And the last kind of important piece of a parabola, key feature I guess you could say, is the axis of symmetry. The axis of symmetry is like the folding line in a parabola. It's like that vertical line right down the middle, where if you were to fold this side onto this side or this side onto this side, they would match up. It's like just the line right down the middle that divides it into two equal, exactly the same identical halves. And the way that we can write or like describe an axis of symmetry is we would say x equals, and then wherever along the x-axis that line is happening. So for example, in this function, it's happening right through 3, right? You have 1, 2, 3. The solutions are at 2 and 4, and the axis of symmetry is right through the middle at 3. So if we wanted to write an equation or say what the axis of symmetry is, we would just write x equals 3. And that's how you can write the equation for an axis of symmetry to say what it is. Just x equals, and then wherever it's crossing through the x-axis at. And that is pretty much all the important points of a parabola. And so now we can talk about them.